All right, so welcome everyone to this session. I will actually present today together with Alexander Meier. He is the CEO of DeepSight, and DeepSight is a company that focuses on AI-based classification of open-ended text answers, for example, from survey data. And myself, I'm actually a senior methodologist at DVJ Insights. My name is Vroegrijk. And DVJ Insights is a Netherlands-based market research company, but we also have offices in London and in Hamburg as well. And some of the sessions today already covered the COVID-19 crisis, and that was actually the point of departure for our study as well. Because what we observed through studying newspaper headlines, but also through our own research, is that the COVID-19 crisis actually made quite some changes to consumers' choice behavior, to their choice processes. For example, we saw a shift from offline to online shopping, for instance. And of course, it's quite nice if marketers get some more insight into those changes in choice behavior, because they can actually adapt their marketing strategy on that. So for example, before the COVID-19 crisis hit, people might actually shop for groceries in a store that's primarily close to them, that's conveniently located, easily reachable to them. And location might play a very large role in their choice behavior. But after the COVID crisis, suddenly location becomes way less important, because people shop less frequently, for example, and instead price now becomes more important in their choice of preferred store, for example, because many people were actually financially hit by the crisis. And also other factors like, for example, the COVID-19 related policies that are in place might now start to play a role as well. And of course, when a marketeer has knowledge of those aspects, they can adjust their marketing strategy better towards those aspects. So how we normally get more insights into choice behavior of consumers in market research is, for example, through driver analyses. So for example, we ask respondents in a survey which stores they actually consider, which of those stores they actually prefer. And then by also asking what people think of those stores in terms of different image aspects. So for example, the price level of the different stores that are available, the location, the quality of the assortment, the actual atmosphere they experience in store. We can actually explain their choices from the opinions people have on those different stores. And we can actually infer through driver regressions which of those image aspects are actually more important versus less important in determining what stores people actually prefer. But then the question, of course, becomes, how can we measure store image within surveys? And the most traditional way in which we can do that is actually through closed-ended statements. So for example, using Likert scales, as you see on the slide here. So we would, for example, compose a set of predefined statements, for example, on the quality of the assortment, the composition, the pricing levels, convenience, these kind of factors, and actually ask people to indicate to what extent they agree or disagree with those statements for a specific store. Now, the advantage of that approach is that it's highly standardized. So it means that we get scores that are easily comparable both across consumers that fill in the survey and also across different time periods. And as such, we can easily use it in quantitative analysis. The disadvantage, however, is that we as researchers introduce some kind of bias to the aspects we consider to be important factors for store choice. I mean, we predefine the set ourselves. So we already say beforehand which aspects are likely to play a role. And some aspects may be inflated in terms of importance as a result of that, while we might miss other ones that are relevant. And so as an alternative, we can also use free associations. And that means that we ask respondents to just spontaneously write down everything that comes to mind when they think of a specific store. And so, for example, one consumer might say that when they think of a specific store, they see it as expensive, but it also offers quite a nice variety of choice. There's friendly personnel employed there. They have express checkouts, but they hate the marketing campaigns that this store employs. Advantage of this approach is that the researcher does not define a priori which aspects of store choice are actually important versus less important. Consumers come up with that themselves. And as a result, this type of analysis will reveal the aspects that are actually most important for store image for consumers. But of course, at the other end, it will result in large amounts of unstructured data that is therefore not suitable for quantitative analysis. And that's why we actually cooperated with DeepSight on this, and which will be told about later on in this presentation. So what we actually want to do is to compare both measurement methods. Is there actually one of the two methods preferred over the other, or are they actually more or less comparable, and do they each result in their own insights? So to do so, we send out a survey to about 550 Dutch respondents, and we actually try to identify their store choice processes in 3 retail categories: groceries, fashion, and electronics. And for each of those categories, we first of all asked respondents which was their evoked set, so which are the stores that they actually have on their short list, which do they actually consider. And then for each of the stores they consider, we ask them what they actually think of those stores. So what is their opinion on the stores, both in terms of closed statements that we defined, as well as through free associations. And then at the end, we ask them what store they actually preferred of the different stores in their choice set. And so for the closed statements, we actually went to the store choice literature in academic journals, and we identified a set of 16 statements that we wanted to include in our survey, distributed across 9 different categories. So you see that some categories, like for example pricing and assortment, have multiple statements associated with them, while others, like for example the COVID-19 policies that are in place in stores, only have one statement associated with them. And for free associates, we of course asked respondents just to name everything that came to mind when they thought of a store. And as you can see here on the slide, this is actually the word cloud for the associations for the different grocery stores that consumers came up with. This does indeed result in quite a lot of unstructured data. And so that's why we eventually turned to DeepSight to get some structure into this data, to make sense of this data and to classify all the different open-ended answers into a much more manageable set of different association topics. And how this is done, this is what will be told by my colleague Alexander, which we will now turn to in this presentation. So over to you, Alexander.
All right, thank you, Mark. So how does this look from a methodological perspective? So we have all this unstructured data, and at the end, our goal is to find meaningful topics. So as a first step, I need to clean data. So I have those comments, and well, there's always some nonsense in it. And we have different AI models that can identify comments that are not really useful to us, like I've never heard of the product, or I don't understand, or don't care, whatever. Also something like no issue, someone just writes okay. This highly depends on the question if we should leave it in or not. Additionally, insults are taken out. I spared you with the examples, but in total, this helps us to get the most valuable comments and get rid of stuff that like clutters our topics at the end. Now, as a next step, I want to increase the quality of the comments we have so far. And for this, we do spell correction. And I mean, you probably know all the fails with autocorrect and that it can easily destroy more than it brings you. But for this, we use, for example, the edit distance. So if you have a misspelled version and there are only 1 or 2 small changes, like getting rid of one letter, then we can correct it. Another thing if there's like a word really well butchered, then we can use context models, and they're based on collocations. So this means we have words that co-occur together, and from this we can extrapolate like what the real word should have been. We can correct it. Now, we need to process it and make it readable for the machine. And in order for this to happen, we need a whole team of AI models. And each of them is highly specified for one task. So just to give you a few, one is the tokenization. So we have the string and we have to like separate it into words and sentences. And then we take the words and use only the word stem, or the lemma, it's called, to get rid of plurals or declinations, etc. Now, if the comment is a little bit longer, we can use a part of speech checker to identify which part this word plays in the sentence. Also, stop words are not really valuable, so we can eliminate them as well. Now, to get more into the direction of topics, n-grams are highly interesting, because if we look at all the comments given in that study, we can identify word groups that occur very often. For example, a bigram would be customer service, which is quite common. Now, the next step is even to relate words as synonyms or antonyms to give it already a direction and like to aggregate more information. Now, we take all this, put it in a vector, so it's just a long list of numbers, including all that information and the position in the sentence, etc., and context, which can be thrown into the AI model for topic classification. Now, just a short excursion to machine learning types, and I want to use pictures for that because image classification is a little bit more attractive to look at. So let's imagine you have tons of data, images, and you want to find out the dog race Airedale Terrier in this case. You have on the one hand supervised learning. So we label each image and say, okay, this is a terrier or not. Now, the counterpart to that is unsupervised learning. So we don't give out labels, just give it the data, and the AI model tries to learn the rules and patterns by itself. Now, with the label data, can put this into a classifier, it's just the actual algorithm, and apply it to a test data set for evaluation. So here we can ideally distinguish Airedale Terriers from corgis. Now, over the last years, deep learning emerged, which gave us many new possibilities. And one of them is transfer learning. So normally you have to start from scratch. So the AI model has to learn what pixels are, what colors, what shapes, and then what pets are. And with transfer learning, we can do this with a minimum amount of data for training, and then apply it to a new dog race, like Wiener dog in this case. Now, how does this look like for text? So it's basically the same system, and the supervised version is some kind of a draw system. So we can use a codebook or a label data set and train on that. This has the advantage that we can reuse those categories, which is very helpful for repetitive studies or if you want to do the same survey in different countries. This gives us a lot more to compare to. Additionally, depending on who did the labels, you want to convey some sort of expert knowledge perhaps, and you can transfer this to an AI model to have like a signature quality. Now, the other part is the unsupervised, like a free text analysis. And it's not completely unsupervised because we use pre-trained models, also from deep learning, where there's a basic understanding of text, of grammar, of letters, etc. But then the input data is not labeled. We throw it into the algorithm, it's self-optimizing for quite a while. And at the end, it says, okay, ideally, I have 12 or 35 topics, and those are my suggestions. This has the advantage that you have some sort of unbiased results, and it's explorative. So you will find out new topics. For example, 3 years ago, Corona was not really a topic, and now it's very dominant. The same is with the Ukrainian-Russian war. And of course, you save a lot of time. You don't need the code book, and at the end, you can still adjust the topics. Now, the fun comes in if we use both of them in combination, like a hybrid version, and that's what we did in that study. Now, there are many other use cases for text analysis. Just to give you a short example, like 3 examples, you can use audio and speech-to-text algorithms to create a transcript from interviews or meetings and instantly find out what the important topics were to talk about. You can do all kinds of iterative matching. For example, you match user input to product descriptions of Amazon, or you can even scrape data or gather data from websites, news magazines, social media, and do a thematic or sentiment analysis. All right, so much to that, and further with Mark.
So thanks, Alexander, for the explanation. So indeed, after employing both of the methods that were just discussed by Alexander to our free association data, we were actually able to add quite some aspects that are potential drivers of store choice to our data set. So first of all, some of those aspects were already covered through our closed statements, but were then again confirmed by the free association data because more or less similar topics popped up in the free association data as well. So for example, factors related to pricing and quality. For other aspects, we did already cover the broad categories that those topics cover, but we found different aspects in the free association data. So for example, in terms of in-store service, we now also found association topics related to checkout time, the presence of self-checkout counters, and for example, in-store factors like cleanliness. And added on top of that, we also uncovered some entirely new categories of potential store choice drivers. So for example, we had the country or region of origin of the store being mentioned, and also factors related to marketing, the advertising campaigns that were employed by the different stores. So what we then did was to test both of these methods through driver analyses. So we actually estimated different models, one of them, for example, only including the closed statements as explanatory variables of store choice. And another one only include the free associations as explanatory variables, which we could now quantify by 0-1 variables, because we now have a much more limited set of topics instead of the open-ended answers to work with. And in a final model, we actually combined both of those two methods into one single model. And when we then look to how these models perform in explaining the store choices that consumers make, we actually found that the two methods do not really differ that much from one another in terms of explanatory power. So the hit rate, the percentage of choices you can correctly predict by the different models, is actually quite similar across both the closed statement method and the free association method, especially when you look at the averages across categories. However, when we combine both methods, we actually see that the hit rate and thus the explanatory power of the model improves quite a bit, especially in the electronics and fashion categories, but the average improvement is about 10 percentage points. So that's quite considerable. When we then look to the actual drivers of store choice that we identified, we see, for example, for the grocery category, that some of the drivers were actually identified through both methods. So both through closed statements and also through free associations, like the positive impact of attractive price promotions and the presence of certain COVID-19 related policies. But some factors were, for example, only uncovered through the free association method because they did not have a closed statement associated with them. So for example, there's the location of a store. And other factors, those were only identified through the closed statement method. So for example, the environmental responsibility displayed by different stores did turn out to be a significant factor in predicting store choice, but it was not spontaneously mentioned by consumers in the free associations. However, we did have a closed statement for it, so we were able to capture that it indeed has a significant effect on eventual store preference. And I will not cover every category in this presentation, but suffice to say that we found more or less the same pattern across other categories as well. So for example, the fashion retail category, we again found that some drivers are identified through both methods, again, price promotions in this case, while other factors, like for example, in-store factors like crowding, are only uncovered through the free association method. We did not have a statement for them, but they were spontaneously mentioned by respondents. And other factors are then only identified through the closed statements then again. So what we can then conclude from all of this is that first of all, we were able to employ an AI-based classification algorithm to our free association data, and that did allow us to use this data in a quantitative sense. So as a result of that, we were able to compare it with the general method that is used for these type of analysis, namely closed statements. And the themes that were confirmed through the free association method, they confirmed both some of the topics we already had in our closed statements, but also added some additional ones as well, which we would not have uncovered by just using closed statements. However, these closed statements still have value, because in each of the retail categories, we actually found that some factors that influence store choice are only uncovered through the closed statements. So people did not mention them spontaneously, so they're not really top of mind when thinking about certain stores, but it did turn out to be a significant factor in driving store preference when people are asked for them. So indeed, this method is still important to explain store choice processes. On the other hand, we have the free association method, which results in the identification of a separate set of factors as well. And as a result, topics that are uncovered through the free association method can also be an important factor that influences store choice. And you would likely need the free association method as well to get a as much complete as possible picture on what exactly the influential factors of store choice are. And that's why we actually would say that both methods combined is actually the best thing to do, because both of these methods bring their own insights to the table. So a separate set of predictors is actually unveiled through both methods. And when you combine them both into one model, you actually get a model that is better able to explain the choices that consumers make between different stores than if you would use each method separately. So that's what we mainly wanted to talk to you about today. Are there any questions?